All right, good morning, folks. Thanks for popping in. It is Friday, a bit of a fun Friday. I like to do a little something different on Fridays, just going to break up the monotony of the week. And today we're going to actually put our hands on this welding machine. We've been talking about welders for a while, last couple of days in the slideshow. So today we're going to break it down a bit and talk about parts and pieces, how it works, what makes it tick. Firstly, this here is a setup that is very common. I've got 3 of these in the classroom. I got some other different welding machines, but this is one we're going to go over today. And there's multiple components to this. So we got a big rack here and it holds multiple parts and pieces, but if we really just kind of look at it from the side, this here is what we're going to start talking about. That is our Miller XMT350. Fantastic machines. They're great. They're a true power source. So we often call these machines a power source, and this is one because you can do multiple things with it. You can use it for stick welding. You can use it to supply power to other things, such as this guy right here, which is our wire feeder. So we take a power source machine that normally has our lugs on the front for stick welding, and we plug this cable in here. This is our power supply and juice for that guy up top. Here's our remote contactor for that. So this remote contactor is a 14-pin setup. This needs to be in for that to work. This power cable here, if we trace this all the way back up, goes right into the back of this wire feeder. And then it's got a jumper that runs to the other wire feeder. So that provides power to this unit. This unit here is our wire feeder, and it can actually run 2 different rolls of wire on it. I'll talk to you about that, but we're going to talk about the power source right quick here. See if I can bring this in a wee bit. That's it. All right. So you may not get a lot of me, but we'll talk about this thing. Self-filming is kind of tough today, but we're going to try and get there. So XMT350 power source. Pretty common, pretty simple machine. What we have here is a big old power switch on the bottom. Up we go. Obviously in the on position, light's going to turn on. Got 2 different readouts there. So one is going to be voltage. This is our voltage for that machine up there. And if we say change this to stick, we got a dial control here. So anything in the orange means it's ready to go. Power's always on. Anything in the white here means you have to physically turn the power on. That could be via a switch. Our MIG setup, that's the trigger. So the MIG setup right here is in the white. But you basically turn the power on by squeezing that trigger, telling this thing you want to weld. If we set this to stick, go over here. So we got different numbers. You probably can't see that. 71.2, that's our open circuit voltage. 85 is our amps. So we got an A here for amps, V here for volts, and that's that readout. So this can adjust. Now I'm running 205 amps, but we're going to talk about MIG settings. So we're going to flick this back to MIG settings here. Close that up. 14-pin connector. That's our inputs for this guy. That transfers the measurements, or not measurements, the settings here up to in here. Also provides power. Then we have this lug here. That's our juice. That's our juice for welding. And this bottom one here is our ground clamp. Ground clamp is part of the system. So let's start there, because a lot of people will disagree, but I think it's one of the most important parts of the system, because without that ground clamp, you got nothing. You're not welding, not doing anything. So we're gonna kind of break it down a bit, set the stuff off the side. Okay, right here, ground clamp is connected. This cable is right down here to this guy. So spring clamp connected by a bolt here and a lug. This connects on your work table or your work piece. Put that on there, take a welding gun, pull the trigger, electricity can flow in a loop back to the machine. That's what we're looking for. We want that circuit, the closed loop. This isn't connected, the wire's gonna come down, hit your piece, and batch off of there and do nothing, and just spit out a bunch of wire that isn't burning. So it's got to be connected. So we're going to set this aside. So this machine has handles on the side. You can kind of see it right here. I just wrap this lightly around there, a couple big loops. I don't wrap it super tight. We don't want to kink and break that cable. So yeah, we just wrap it nice and light. We don't want to break that cable. It's fairly thin. These can be removed. These are twist connect lugs. So you can twist it. And then once you twist it, this can pop out of here. I don't take these ground ones out very often because you always use them, but there's a lug here. It's got a little lineup dial on it. That's going to line up with a little hole here. So that's where it goes in. So you pop that in there. Turn it to the right. It'll stop. That's locked in. This one's our power for the top unit here. For this guy. Almost lost my laptop. That was scary. This is a wire feeder unit. So this can all be taken apart off of this. This is just sitting on a cart. That's all it is. And this unit has a bunch of different things going on. So a bunch of dials and stuff on the front, but we're just going to go over the main components right now. We're going to turn this sideways here so you guys can get a better look at it. And what we have here, our roll of filler wire. So this is what makes our weld. This is what is basically the wire we use to make our weld with. This wire will mix with the base metal and to create the weld on those things there. So this big roll here, 44 pounds. The other roll, other side, the 035 S6 hard wire, that is 44 pounds as well. And I did a little exercise in my 20s this morning on a brand new roll of 035 S6 wire at 44 pounds. We did some measuring. We weighed 1 foot of wire and we calculated how much wire is on one of those rolls. There's 14,080 feet of wire on one of those rolls. So if you were standing at the front doors of Bishop McNally, you walked to the corner, then you walked down the sidewalk to McDonald's, you got yourself a burger and you came back, that would be 4,000 feet. You'd have to do that trip 3.5 times. So McNally, McDonald's, McNally, McDonald's, McNally, McDonald's, McNally, and then down to McDonald's one last time to equal 4.3 kilometers. So that's a lot of wire on one of those rolls. So that was what we did this morning with my 20s, worked that math out. Little fun fact for you. This here is our driver. This is what pushes our wire out of here. And our system right here is a dual drive roll system. So these top two are idlers. They're not motor driven. So that'll lift up. But they're connected with a gear to these ones here. So when I turn this on, all 4 of these are going to spin at the exact same time. And we'll do that right now. So this is on. What I'm going to do is I'm going to turn this wire feeder on. Then we're going to jog this. And all 4 of these are going to turn at the exact same time. They're interconnected by gears. That's how it happens. It's a 4-wheel drive wire system. There you go. You see that? All at the same time. What I can do, I can pop this open. I can hold these 2 idlers up, and it's just going to drive the bottom 2. See, the top 2 aren't turning now, but if I drop them in, gears mesh and they start driving. So that's how they control the speed of the idlers, by gears connected to the drivers on the back. So your wire is going to come off the roll into the back, so through the drive rolls here into the back of the gun. Now the back of the gun, pretty important. Let's wrap some other stuff up here. Well, we're talking about the drive rollers right here. This is the back of the gun. Quite important. 2 important things about it is it has a cable attached to it. That cable right here, you can see, is our trigger inputs. That sells basically the drive rollers here that it's time to do some moving. So this is a small pin connector right there, 2 pin, very delicate. So we don't really play with this too much. I like to take it apart and show you guys, but we leave that right there. Connects to the front of the machine, and that basically tells the drive rolls to move when we pull the trigger. It's going to feed that wire down through here. But also, we got this guy right here, this big thing. This is our gas bottle. This is what shields our weld. We need to have that shielding for a weld because oxygen is just going to mess up that weld. It's going to be no good, right? So this is 75-25. So 75% argon, 25% CO2. This here is a dual setup. I could actually run a second line off of here and be shielding a second welder, but I don't have to because I've got the single line here, comes out to the back to a Y splitter, and then it enters the back of this wire feeder here. See if I can show you guys that. So this green cable goes down, loops around, comes back to this Y splitter here. This splitter delivers gas to both sides of this machine because we can run one gun right here. And if I had a second gun, I can put a second gun right here. So we need gas for two systems. So that's what that splitter does. Pretty cool system. But what happens, we're just going to kind of focus on this side. And you can see here, right here, that's a gas line that comes in the back of here. So, let's see if I can turn this a bit so you guys can see this next part. This next part is kind of important too. Looking at the front of this gun, we have our trigger connect, right? But if we look down here, it's hard to see. There's a little rubber hose, and that comes off the gas solenoid. So there's a gas solenoid inside this blue body here. And when you pull the trigger, it tells the gas solenoid, hey, we need some gas. So it shoots the gas down into here. What happens is that feeds into this collar. This collar, there's a piece in here. Once that collar is filled full of gas, it'll fill this full of gas. And I'll show you that and how that works. So pop that trigger control out. So we're going to take this gun out. Now loosen this up here, the little hand wheel. Then we just twist this out. And we got the end of the gun. So this fits up inside of there. There's two rubber gaskets right here and right here. Super important that those are intact because if not, gas is going to seep out past this and you won't get all the gas down your gun. But holes here. See, there's a hole there. There's a hole there. That's how the gas gets in here. It goes into a liner and comes down the end of the gun, basically all the way out the end of the nozzle. So we're going to grab that and talk about that. Just going to connect all this so I can do this again in a bit. So that's back in connected. We'll tighten that up. Then we're going to talk about the welding gun. Okay, so we got the welding gun. One of those things I talked to you guys about was when we pull the trigger, three things happen, right? Three, not four, three. Three things happen. So this trigger does a lot of stuff. Basically, what's going to happen is, first one, like we talked about, gas solenoid. So I don't know if you guys heard that, but gas comes out of the end of the gun. So what it does is it tells the gas solenoid, hey, open up, we need some gas. That gas is regulated by the regulator from the bottle, right? Because the bottle is about 2200 PSI working pressure. We use a regulator, or not 2200 PSI working pressure, 2200 PSI bottle pressure. The regulator brings it down to the working pressure. That working pressure is going to be about 25 CFH, 25 to 30. We don't really need to go higher in here. Nice controlled conditions, no wind. Don't really have to worry. 25 will be just fine for what we're doing. But as you can hear, that's that gas coming out at the end there. Second thing that's going to happen, pull the trigger. Those wheels starting to spin, right? So we're going to drive that wire if there was wire in there. And then thirdly, when you pull this trigger, it also tells the contactors inside that, hey, we need some electricity. That electricity gets delivered through a wire here into the back of the contact tip, which is this guy right there. And that gets energized. And that makes contact with your wire. So your wire runs up to the middle of that. Once your wire runs up to the middle of that, you pull the trigger, this gets energized, it puts energy into your wire, and then that's what gives us the power to weld. So those three things that happen is kind of like a welding triangle. When you guys are younger, did you guys learn about the fire triangle? How it's fuel, heat, oxygen? Those things, without one, it's going to collapse. Same thing with welding. If you don't have every one of those components, if you don't have the wire delivery, if you don't have the gas delivery or the power, you're not getting any welding. So that's going to stop welding or won't weld at all. It's kind of like a fire triangle or a welding triangle for MIG welding. That's kind of a cool concept there. That's how I remember it. Hopefully it helps you guys with that, because that will be on the test. So yeah, we got the gun. Inside that gun though, there's a few more things. So we have, I think, lots going on inside of this. So let's kind of break it down what happens in here. In here we got about 5 different wires inside of this here. So we want to protect these. We want to be careful with them. We also have a liner. That steel liner is what our welding wire runs through, so it doesn't wear holes in this or cut holes in our cables. Then we have a bunch of fluff material in there. Not fluff, it's corded material. Helps keep the shape of this, stop it from folding in half, because when we put a bend in this, that puts resistance on the wire, makes it harder for those drive wheels back there to drive it out the end. And if for some reason it can't drive the wire out of the end here, what happens is back on the wire feeder back here, you're gonna get what's called a bird's nest. It's gonna be pulling wire off of that roll and then shooting out the side here in a big coily mess. We call that a bird's nest. That's what that is. So in here we have trigger controls. So we got 2 wires for the trigger. In here we also have our gas hose. And then also in here we have our electrical wire that provides our power to the contact tip, then our liner, and then our insulating material. So lots going on. If this gets damaged, it's a bunch of money. So we try and keep these intact, and we try and treat them with care. So since there's so much stuff going on in here, a big part of taking care of these is wrapping them up nicely. Not dropping on the ground, because if we break contacts in the trigger, it's gonna wreck that. Bunch of stuff that can go wrong up in here. As you can see, someone's laid this on some hot material, burnt a nice hole in the side of it. Luckily, still works. Otherwise, we have about a $500 bill. So, and I wouldn't be the one paying for it. So whoever damages it, unfortunately, if it's a complete neglect, they would be on the hook for the repairs. But we're gonna try and avoid that. We're just gonna keep all the stuff intact, keep it running good, treat it nicely. So part of treating it nicely is when we wrap it up. I'm gonna show you guys how we do that. Because as we know, we've all had headphones that have stopped working on us, right? You jam them in your pocket, the wire gets broken eventually, one earbud keeps cutting out, and then you just get mad at them, you throw them out, you get some new ones. Same thing could kind of happen here. So we want to wrap this up nicely. You can see it comes out the front of the wire feeder here, down, it's about 15 feet. And we want to wrap it up nicely. So I'm taking a big loop, wrap it over these handles here, bring it down again, and just like that. That's all we need to do. Big loops. That way we're not crushing, pinching, or bending the wires. So that is that part. So let's talk about how this wire feeder works. Talked about the components. Now let's talk about how this feeder works. All right, turn this a bit. All right, see some numbers on here. Cool. Slide this up. So there. Maybe we'll get right in tight. Hopefully you guys will be able to see that to some extent. Might not be able to see the readout, but at least I'll be able to talk about this and you guys will be able to see how this works a bit. So we have wire feeder. Cool thing about this, it's designed for 2 different rolls of wire. If I do this, you can see flux core and solid wire on the back, 2 different rolls. And that is nice because that way you're not wasting time changing things. You can actually flip this from one side to the next if you had 2 different guns attached. I do have some machines that have 2 guns on them. Only one of them though. These guns are expensive. I don't like to buy more than I need. So the way I teach my units, generally we don't have to change these over too much. But what happens is we're gonna look at this unit here and we're gonna talk about these numbers, these dials, these buttons. Basically, this unit has an on-off switch right down here by my finger. Press it off, lights will go off in about a second, And there we go. And yeah, so this one always needs to be turned on. Just because the bottom unit's on and providing power, this doesn't mean that this is turned on. You see the lights? Good to go. So we're turning this back on. And we see it's just kind of figuring itself out. Puts out some numbers right here. If you guys can see it, numbers are 24.9 and 332. And we got this here. I don't know if you can see it. It's illuminated. See that green light? That is indicating what side it's on. So it's talking about this side here. We don't want this side though. We don't want to work with this side. We don't have a gun over here. It's empty. There's no gun. So press the toggle button, the other side, green on the right. There we go. So now we're going to work on this side here, one with the wire. Because we can see got the wire back there. We have the drive rolls, gun. What this machine does is it's got these little knobs here. These knobs are your controls. And this one here, labeled wire feed speed. This one here is labeled voltage. Quite simple. When working with gas metal arc welding, we talked about voltage and wire feed speed, their relationship, how wire feed speed is actually the amperage, the voltage, it's the burn off rate, the power to do that with. And they have to be kind of in line with each other for them to work. Otherwise you get stubbing or arc hunting. So we got way too much wire, not enough power to burn it off. So we got 18 volts and 400 inches a minute of wire. That wire is going to come down and bash off that plate. It's going to pop, explode. You have chunks of wire flying everywhere. You're not going to create a good weld. You're just basically going to waste gas, wire, your time, and risk your safety as well. Because some of this wire can pop up, maybe jump down your neck, give you a burn. Not something that cool. On the opposite side, you're running 26 volts and 180 inches a minute of wire speed. What's going to happen? That wire is going to come down, touch the plate, boom, burn way back, come all the way down, touch again, burn way back, and sometimes it'll burn back to the contact tip, weld itself to the contact tip, and those drive rolls, they just want to push wire, and all they do is they spin. So what's going to happen, it's going to push wire, that wire is going to come out the side of our drive rolls, and it's going to be a bird's nest because that tip is welded shut because we had such an imbalance in our levels, our voltage and amperage. So that's kind of a stubbing and arc hunting thing. I'm going to show you guys demos of that in class because it is something you need to know. I'm not going to be able to be helping every single person all the time in this class. So knowing a bit of troubleshooting skills, some basic diagnosis is going to help you guys out. So I'll give you some examples, some extreme examples, some not so extreme examples, show you guys how to help yourselves if you do find something isn't working right. So we got a couple buttons down here too. You see these are divided as well. I may not be able to read it, but this is trigger hold. We don't really worry about that. We only use this when we're doing really long, big welds. Then we got purge and jog. So jog is what I'm going to use when I want to turn the drive wheels and bring wire out of the end of the gun, but I don't want to release any gas. So what happens is this independently turns on the drive rolls. So if I turn this sideways a wee bit, hopefully you guys can see right there. We'll turn this a bit. These drive rolls right here should be turning all by themselves. No gas going on. The opposite side, the button on the, because these are toggle buttons, you press the lower side, that's the purge button. That's going to shoot gas out, but not turn on these drive wheels. So you'll hear that now. Well, actually, I need to open this up. So that is shooting gas out the end of the gun, and we use that to clear dust out the end of the gun. Sometimes if we're changing gas and we got some gas in the system, we switch to a different gas, we'll hit purge, push all that old gas out of the system, start flowing some nice new gas in there. Big thing to do with this bottle here, folks. We don't generally touch these settings on the bottom. There's little hand wheels here and here. Here, right there. We don't generally play with those. I've got those set up. What we need to touch though is the hand wheel on the top, right behind this gauge. So this gauge is your bottle pressure. It tells you how much you got in this bottle here. And we are golden. We're over 2,000 PSI. It's a brand new bottle. But this hand wheel at the back, we're going to close that up. When we weld, we need that shielding gas, right? Oxygen is death for our welds. We're talking aero bar central, porosity wormholes, looks like garbage. That's noob stuff, not turning that on. So we turn that on. Gives us a nice, good looking weld, but we need to turn it off at the end of the day because these systems have small leaks. They all do. It's the way it is. They're getting a little older. And if we leave it on for the weekend, that's leaking all my gas out of the bottle. Your student fee is about $30, $28, I believe, actually. This bottle cost me $60. Each bottle cost me $60. So I've got 7 welding machines in here with bottles on them. So 7 times 6, 42 is $420 in gas. And then I have another 6 spares sitting over there in case we have an issue with a bottle or we need to change it. So that's another $360. So we're talking $780 in gas in here. That's a lot of money in just gas for welding. That's not even including the wire. So we need to be very cognizant of turning these off whenever we're done using them so we don't waste gas. Because when we do waste gas, it hurts everybody in here. It hurts my budget, which in turn hurts you guys when I don't get to buy things for you. So very important and just really good practice to always turn that off whenever you are finished done welding for the day. If you're welding in here, do a bit of welding, you pop out in the class, you clean something up, pop back in your booth, weld. I don't need you to turn the bottle off between those times, but end of class, they gotta be off. I check them all. I give heck to whoever doesn't. I kind of give them a gentle ribbing, and then eventually they're gonna learn to turn them all off. It's just good practice. I make sure every night before I leave, I walk every single booth and check them all, just because we cannot afford to waste that gas. But that is a bit of a breakdown on the systems. Pretty simple, pretty neat systems. I didn't really touch on the drive rolls too much, but we can take these out, pop them right out of here. Got one here. Pretty cool little system. So they've got some, hard to see, but they're stamped. It tells you what size it is. These ones here are knurled V grooves. So it's a V groove, so the wire fits in there, but it's knurled, so it can grip that wire and force it down the end of the way. It's pretty cool. Love these things. They're good. They will come in matched sets, so you'll buy them in 2s. But this one here, it's got 045 stamped on it and nothing on the back. Nothing on the back here. So both these grooves are going to be an 045 groove. If it says 045 one side, 035 the other, these grooves are going to be 2 different sizes. So you got to pay attention to that. Flux core is a hollow wire. So we use knurled. We have to use knurled to grip that because we can't apply too much pressure to this wire. Flux core wire is like a soft burrito wrapped up in a circle. Then you got all your filler on the inside, right? So imagine that outside the burrito is steel and the inside is flux, deoxidizers, metal components, and cleaning agents. That's what's inside those flux core wires. So it's hollow. So we need to grip it firmly on the outside with those knurled rollers to push it down the way. Whereas with solid wire, there's nothing on the inside. It's 100% solid. We can put a lot of pressure on that to drive it out. So we use pressure to drive the solid wire, and we use traction to drive the flux core wires, the filler wires. So kind of neat setup. These things work in tandem, really neat. There are different types of guns, but generally what we see here is what we're running in here. And this is what you're gonna see in a lot of different places. I do have some standalone machines as well. They only do one job, and that's push wire. So it's whether it be flux core or MIG, that is, yes, I said MIG, it's gas metal arc welding. So in that slideshow, we talked about how MIG rolls off the tongue nice and easy. So I've been doing this for a while, and I've just always used the term MIG, but it is technically gas metal arc welding because CO2 is not inert under certain circumstances. So that'll be on the quiz as well. Yeah, pretty neat setup here. Super user friendly. What I love is the digital readouts. So you can repeat results exactly. You can tune into exactly what you had last time. In fact, I encourage it. When people find out what they like, I encourage them to write their settings down, be it on one of the standard machines or one of these machines. Throw it in the notes in your phone. Take a picture of it. I don't care. But that way you have it. It's there for you every time, and you can work with those settings only. You can change them, adjust them up, adjust them down, see what works for you. Doesn't bother me, guys, but help yourselves by writing that down, take a picture, store it in your notes, whatever it takes. That's pretty much it for today, folks. What I'm going to do is you got 10 minutes before lunch. I think we're going to wrap that up here. Make sure your name is in the chat if it's not. That was a quick and dirty breakdown of our power sources and our wire feeders and how the system works, hoping to put some context into the stuff we've learned over the last couple days. So with that, you are free to go. Thanks for tuning in. I hope you all stay healthy. Hope you have good weekends. Vaccines, you guys will be able to get them pretty soon. I think they're opening that up. So you can start booking appointments and get yourself vaccinated if you choose to. I have an appointment booked for next Monday, so I'm getting mine, gonna get the jab. And that's one of two. So hopefully we can all get it done, go back to normal summer, and have an awesome 2022 or 2021-2022 school year. No more of this mask stuff, no more of this distancing, online learning. Hoping that's all gone. Anyways, miss you guys lots. Can't wait to have you back here. But the stuff that I'm issuing you guys, if you haven't taken care of it yet, please start taking care of it. So when we get back, at about 15 class days, we got to hit the ground running hard. There's no time to waste when we get back. So thank you much. Stay healthy. Have a good weekend. And I will catch you on Monday online. See you guys.
Bye, mister.